Welcome everyone to our algebra series, the SSCE aspect of it. Today we'll be considering substitution in algebraic expression. There are two types of substitutions in algebraic expressions. A, when the value to be substituted is given. B, solving for the value to be substituted under given conditions. First, let's start with the A, when the value to be substituted is given. Examples under this. Let's take our first example. If P is equals to 2U divided by 1 minus U, and Q is equals to 1 plus U divided by 1 minus U, express P plus Q divided by P minus Q in terms of U. Solution. P plus Q, we are now substituting, is the same as our P has been given earlier as 2U divided by 1 minus U, plus our Q has been given as 1 plus U divided by 1 minus U. We do a simple fractional arithmetic using the LCM. 1 minus U is common to the denominator of both terms. So we have our result as 1 minus U at the denominator. Then when 1 minus U divide 1 minus U is 1, so you just have 2U plus. Also, when at the next item 1 minus U divide 1 minus U, you have 1. So as this is plus before it, we don't need to introduce brackets, so we just write our 1 plus U. The result is at the numerator we now have 3U plus 1 divided by 1 minus U. P minus Q will be equals to, our P is 2U divided by 1 minus U, minus our Q is 1 plus U divided by 1 minus U. And taking our LCM, see the denominator are the same, so 1 minus U will be at the denominator. And we have at the numerator, the first case we have 1 minus U divide 1 minus U, have 1. So times 2U, you just put down your 2U. But remember, before the other item, we have a minus, not plus here. So we have to open bracket. So when 1 minus U divide 1 minus U is 1. So you just open the bracket, then you put 1 plus U, close bracket. We have to introduce bracket because of the minus sign. And when you open up the bracket, the result will be 2U minus 1 minus U divided by 1 minus U. And that will give us, our result will be U minus 1 divided by 1 minus U. And from simple understanding, you can see that the numerator and denominator are similar. It's just a difference of minus. So you factor out minus at the numerator, you will now be given 1 minus U as the same as it is in the denominator 1 minus U. In both terms, we cancel out, leaving us with minus 1. Thus, P plus Q divided by P minus Q is the same as 3U plus 1 divided by 1 minus U, then with our division sign by minus 1. We have just substituted the values we got from P plus Q and the one we got from P minus Q. And changing from division to multiplication, we have 3U plus 1 divided by 1 minus U times minus 1. Remember, the minus 1 was a whole number. So when it's changing from division to multiplication, it becomes 1 over minus 1. So hence, it came down to the denominator. And our result will be equals to 3U plus 1 divided by U minus 1. Another example. Given that P is equals to x squared minus y squared divided by x squared plus xy, I express P in its simplest form. I find the value of P if x is equals to minus 4 and y is equals to minus 6. Solution. We have to simplify the given expression. That is x squared minus y squared divided by x squared plus xy. If you look at the numerator, it's difference of 2 square. So that will give us s plus y, bracket open and close, into another x minus y, bracket open and close. And at the denominator, we just factor out x and we'll be left with x plus y. Sometimes we cancel out and our result will be x minus y divided by x. Substituting for x and y, we'll now be using the simplified form, not the original given form. So our x minus y divided by x will be equals to minus 4 minus, then we use bracket to change the value of y, since it's a minus value this time around, minus 6, bracket open and close, divided by minus 4. At the numerator, you will have minus 4 plus 6, because minus times minus will become plus, divided by minus 4. And that will give us 2 divided by minus 4. Our result will be minus 1 over 2. Another example. If x, y, z are in the ratio 6, 5, and 8, find 12x minus 9z divided by 4y plus z. Solution. From the question, x, it implies that x is equals to 6, y is equals to 5, and z is equals to 8. Substituting 12x minus 9z divided by 4y plus z will be equals to 12 into bracket open 6, bracket close, minus 9 into bracket open 8, bracket close. At the numerator, our denominator will be 4 into bracket open 5, bracket close, plus 8. And when we resolve all this, 12 times 6 will give us 72, minus divided by 20 plus 8, which is equal to 0 divided by 8. And that will give us 0. We've come to the end of the examples under this subtopic. Next, we have some exercises at page 43 of the hidden fact in new SSCE mathematics. Try your hands on the exercises while we quickly move to the next subheading. Solving for the value to be substituted under the given conditions. Undefined expressions. I. Then II. Expressions equal to 0. Now, let us start with undefined expressions. For any expression of the form AS divided by BX to be undefined, then BX must be equals to 0. The following example will explain better how we go about problems of this nature. Let's take our first example. Find the value of s for which the fraction x plus 1 divided by 2x minus 1 is undefined. The options are given. A. Solution. First, we check whether the given expression can be reduced. But from what we are seeing here, the given expression cannot reduce further. So we now know that x plus 1 divided by 2x minus 1 is undefined if the denominator, which is 2x minus 1, is equals to 0. From here, we start solving the simple equation there, which is to say 2x will be equals to 1. And from here, x is equals to 1 over 2, which is to say once the value of x is 1 over 2, the given expression becomes undefined. Let's take another example. For what value of x is the expression 2x minus 2 divided by x minus 2, bracket open and close, into another bracket open, x plus 3, bracket close, is not defined? The options are given. Solution. First, we check our given expression, and we can see that the given expression cannot be reduced further. For it to be undefined, the denominator, which is x minus 2, bracket open and close, into x plus 3, bracket open and close, is equals to 0. And that is to say, x minus 2 is equals to 0, or x plus 3 is equals to 0. And it follows that x is equals to 2 or minus 3. Another example. Find the value of x for which the fraction 2x squared plus y squared divided by x squared minus 4 is undefined. Options are given. Solution. It is clear that the expression will not reduce further. Hence, we impose the undefined condition, which says that for any fractional expression to be undefined, the denominator must be equals to 0. That is to say, x squared minus 4 will be equals to 0. That is to say, x squared is equals to 4. And from here, x will be equals to plus or minus square root of 4. And that will give us x equals to plus or minus 2. Another example. Given that y is equals to 1 minus 2x divided by 4x minus 3, find the value of s for which y is undefined. The options are given. Solution. For any expression of the form ax divided by bx to be undefined, bx must be equals to 0. Here the expression is not yet in full fraction. We will now have 1 minus 2s divided by 4s minus 3 will be equals to, just as we do in normal fraction, we just use this denominator to multiply 1 and we subtract it from the 2s since it's minus that's in between. Hence you have, in the denominator you have 4x minus 3, and in the denominator you have 4x minus 3 minus 2x. And our result will be 2x minus 3 divided by 4x minus 3. And since the given expression cannot reduce further, we apply the undefined condition, and that will give us the denominator be equals to 0. That is 4x minus 3 will be equals to 0. And from here we have 4x equals to 3. Thus x will be equals to 3 divided by 4. Another example. Find the value of s for which the fraction s squared minus 9 at the numerator divided by 2x squared minus 7s plus 3 is undefined. Solution. First, we simplify the expression to see whether it will reduce further. Thus, s squared minus 9 at the numerator divided by 2x squared minus 7s plus 3 at the denominator will be equals to s squared minus 3 squared. Factorizing the denominator using our principle of factorizing the quadratic at the denominator, our AC there will be 2 times 3, which is 6, and the factors of plus 6 that will give us minus 7, minus 6, and minus 1. Hence, we simplify the denominator into 2s squared minus 6x minus s plus 3. And our result will be the numerator is difference of 2 squared, which you have seen clearly there, to be x minus 3 into bracket open, another bracket open, and close, x plus 3. So at the denominator, you just factor out 2s in the first 2 items. You will now have 2s out. You will be left with x minus 3, bracket close. Then you factor out minus 1 from the last 2 items, and you will be left with x minus 3. Going further, numerator still remain the same, x minus 3 into x plus 3. The denominator, you just factor out 2x minus 1, and you'll be left with x minus 3. Bracket open and close. From here, some terms will cancel out. X minus 3, numerator and denominator. So you'll be left with x plus 3 at the numerator divided by 2x minus 1. Next, we impose the undefined condition. And from here, we have that 2x minus 1 will be equals to 0, which is the denominator. And that is to say, 2x is equals to 1. Thus, x is equals to half. Yes, we've come to the end of the examples under this subheading. Next, we have some exercises at page 44 of the hidden fact in SSCE mathematics. I will advise you try your hands on the exercises while we quickly move to the next subheading. Expressions equals to 0. That is solving for value to be substituted under the given condition. Expression equals to 0. For any algebraic expression of the form ax divided by bx equals to 0, then as must be equals to 0. That's to say the numerator is equals to 0. Let's take some examples to buttress our point. For what values of x is the expression x plus 3 at the numerator divided by x squared plus 10x minus 25 at the numerator equals 0? Solution. Since the numerator cannot be factorized further, we impose the given condition, which is to say for the given expression to be equals to 0, x plus 3 must be equals to 0, which is the numerator. From here, we know that x is equals to minus 3. Let's take another example. For what values of x is the expression x squared minus 2x minus 15 at the numerator divided by x squared minus 25 equals to 0? Solution. First, we factorize the numerator. The quadratic at the numerator, which is x squared minus 2x minus 15, will become equals to x squared plus 3x minus 5x minus 15. Thus, we are looking for the factors of minus 15 that will give us minus 2. And the two factors are plus 3 and minus 5. Hence, we have this expression. And what we just do, we factor out x from the first two items in the expression. And when we do that, x into bracket open x plus 3 minus 5, factor out minus 5 in the second group of two items, and you have x plus 3, bracket open and close. From here, x plus 3 is common, we factor it out, and you'll be left with x minus 5. And we can now easily say that our given expression, x squared minus 2x minus 15, divided by x squared minus 25, will be equals to x plus 3, bracket open and close, into another bracket open x minus 5, divided. If you look at the denominator, it's a difference of 2 squared. That's x squared minus 5 squared. So you are will be left with x minus 5 into x plus 5. And if you observe carefully, x minus 5 will cancel out. So you'll be left with x plus 3 at the numerator and x plus 5 at the denominator. Next, we can now proceed to impose the given condition on the reduced form of our expression. So we'll now be left to say x plus 3 is equals to 0. For this expression to be equals to 0, the numerator must be equals to 0. Our result will be x equals to minus 3. Another example. Find the value of s for which the expression 2x squared plus 9s minus 11 divided by 6 minus 4s is 0. Solution. First, we factorize the numerator to see whether it will simplify further. That will give us our 2x squared plus 9s minus 11 divided by 6 minus 4s will be equals to, at the numerator we have a quadratic there. So we are looking for the factors of AC that will give us B. And our AC here is minus 22. 2 times minus 11 is minus 22. Two factors of minus 22 that will give us plus 9 are plus 11 and minus 2. Our numerator will now change to 2s squared plus 11s minus 2s minus 11 divided by 6 minus 4x. And we can factor out x from the first two items. You will now be left with 2s plus 11. And you factor out minus 1 from the last two items. You will now be left with 2s plus 11. And since x minus 1, we can factor it out, you'll be left with 2s plus 11. And if we simplify further, trying to simplify the denominator to see whether there will be similarity between any item at the denominator, we factor out 2, and you'll be left with 3 minus 2x. It cannot reduce further. Hence, we impose the condition of the expression equals to 0. And that is to say, our numerator, which is 2x squared plus 9x minus 11 will be equals to 0. And that's the same as saying that x minus 1 into bracket open 2x plus 11 bracket close is equals to 0. And that is to say x minus 1 is equals to 0, or 2x plus 11 is equals to 0, or 2x plus 11 is equals to 0. From here, we know that x is equals to 1, or 2x is equals to minus 11. And from there, we know that x is equals to 1, or minus 11 over 2. We've come to the end of the examples under this subtopic. Next, we have some exercises at page 44 of the hidden fact in new SSCE mathematics. Try your hands on them. The answers are given at the answer section of the book, either the hard copy or the soft copy. Thank you.